All right, so, no, restart that. Action. So, in our last video, I redefined this problem so that we would have a 2.75 seconds instead of a 4.75 because it changes the dynamics of the problem and how we visualize it. So I'm going to go ahead and go through with a 4.75 seconds for a time so that if any of you have already done this problem, you have an example as well to see if you went about it the right way. So let's right off the bat, let's get our equations listed and our variables listed. So we've got an S equals xi plus vit plus 1/2 at squared. An a equals vf minus vi over t. And then listing on our variables, s, xi, vi, vf, a, and t. Now, what do I know right off the bat? Well, I know my 32 meters per second. That's going to be my final velocity, the same as the last time I did this. That's not going to change. I know my time is going to be 4.75. And I know my acceleration is going to be due to gravity. Now, the way this problem is going to work differently is how I initially imagined this being set up, is that you're sitting at a desk. Such a handsome student. And I'm up here and shooting a Nerf dart down at you. But with 4.75, what this is actually going to end up looking like, and I'll show you the math behind it, is that I'm in the ceiling and I shoot the Nerf dart up, and then it arcs down to come hit you. Okay? So we're going to see why that happens. But either way, all of that motion is being affected by a free fall. So it's going to have that same acceleration of negative 9.8. Negative 9.8 meters per second squared. And then we're going to set up how we're going to solve this problem. So the first thing we need to know is, what is our reference point? Well, our reference point is going to be wherever we set our zero position. I'm going to set it, again, like I did in the last iteration of this, as the ground. So the ground is 0 meters. So the student's head is 0.75 meters. And I'm going to once again set this as up is positive and down is negative. Okay. So then let's do our first part. A, what is the initial velocity of the Nerf dart? We're going to solve it the same way. We're going to do A equal to VF minus VI over T. We're going to rearrange that, so AT equals VF minus VI. AT minus VF equals negative VI, and then multiplying everything by negative 1 is going to get me VF minus AT equals VI. Plugging my numbers in for that, that's going to get me 32 minus negative 9.8. This is a negative 32. Can't forget that. Times a 4.75 seconds. That's going to get me a value of 14.55. A positive 14.55. I'm going to put that in over here. Okay. So this is why I wanted to change that number, because this would be a little confusing, because my initial velocity is positive, but my final velocity is negative. And that's why it's going to look like this arc right here. Because if my initial velocity is positive, it's going upwards at 14.55 meters per second. And then it's going to arc down and ultimately hit with 32 meters per second going in the negative direction. So that's why I wanted to change it, just so we could get rid of this arc, because I felt like that would make things a little confusing. So let's finally go through and solve for our xi. We want to know the height of the ceiling. That's our starting position. So we're going to need to solve for that. our S equation is still going to work the same way that it did before. So my S, my ending point, is going to be that 0.75 meters off the ground because my S is always the end of my movement. My XI is always the beginning of my movement. So 0.75 meters for my S. And then let's set up our S equation. So S equals xi plus vit plus 1/2 at squared. All right, S is equal to 0.75 equals xi plus vi, which is 14.55 times 4.75 plus 1/2 negative 9.8 times a 4.75 squared. Now, I'm going to simplify everything from here to here because I have all solid numbers here. I don't have any variables in there, so I can multiply these two together, multiply these three together after doing this exponent, add the two together, and it won't affect anything else in the equation. So I'm going to do that, but then I need to remember that I still have a 0.75 and an xi that I still need to carry down to the next part. So that's going to give me negative 41.44 plus xi equals 0.75. Now notice that gets me a different value than it did before because this part of the equation is ultimately telling me how much movement did I get up to this point. And everything after that is covered by this part of the equation, all of this motion. It can be a little bit confusing to think about, which is why I wanted to change it. So let's go ahead, add 41.44 to both sides. It's going to get me a 42.19 was my xi. Okay. 0.19 meters. 42.19 meters for my xi. 14.55 for my vi. And this problem is solved.